Welcome back. We are ready to do an actual goodness of fit test on our household income example. So again, the economist wants to know if the distribution has changed since the year 2000. So that she's got information from the year 2000. That's giving us expected counts from her randomly selected 1,500 households, and she observes values from them, gets a distribution, and we're going to test it against the 2000 distribution to see how well they match. The table below shows the number of households in each category, the observed counts, and also the expected counts under the assumption that the distribution has not changed since the year 2000. And then we want to know, does the evidence suggest that the distribution of income has changed since 2000 at the alpha equals 0.05 level of significance? Okay, so here's the table. Here's what she observed. These are her 1,500 households. 130 of them fell into the first category, 137 into the second, etc. These expected counts are exactly what we computed earlier. So these are from our work where we took the year 2000 probability of being in category 1 and multiplied it by the 1,500 households. Year 2000 probability of being in category 2, and we multiplied it by the 1,500 households. So again, remember what this expected count is if the distribution is the same with the same relative frequencies and probabilities, if it's the same as it was in 2000, these are the numbers we should get. Now, you'll never probably get the same numbers if, with a different sample, especially taken at a different time. But how far off are these? Are they so far off that the distribution would not be considered the same as it was here, or are they close enough that we don't have evidence to say that it's changed? And again, the level of significance we are looking at is 0.05. Okay. Now we don't need that for our test statistic, but we will need it to get the p-value. Okay, so what are our hypotheses? Well, the null hypothesis is always that the distributions match, that they're in some sense the same. So our null hypothesis is going to be current household income distribution is the same as in the year 2000, and our alternate hypothesis is going to be that it's not the same. So current household income distribution not the same as in the year 2000. Okay, so you remember how hypothesis test works. We assume that the null hypothesis is true. We look at our observations and determine the probability of getting those observations if the null hypothesis is true. If that probability is very, very low, or is too low, I guess I should say, then we will say, the null hypothesis must not have been true, or we wouldn't have observed the values that we did. Okay, we do that using test statistic. So using the test statistic formula, well, I'm not sure where that went. That's okay. So remember I'll just write it here. So the test statistic formula, and the book's probably calls that chi-naught squared, is the sum of the observed values minus the expected values or counts divided by that expected value. So in this case, we have, and you might want to write a little bit small here, first observed value for category 1 is 130, and we're subtracting the expected count 105. Oh, and those are squared after you do the subtraction, and divide by 105. Okay, and then remember the sigma means add, so we then have, for category 2, observed count 137 minus expected count 129 squared over that expected count 129 plus 150 observed count minus 139.5 expected count, square the difference, divide by the expected count. Keep going. 207 minus 214.5 squared over 214.5. Couple more to go. 291 minus 295.5, difference is squared, divide by 295.5, and two more. 202 minus 225, difference is squared, divide by that expected count, and one more category. The seventh one is 383 minus 391.5, difference is squared, and divide by the expected value. Okay, you crunch all that and you get test statistic 10.105. Now if you go, so from that we need our p-value. And let's remember, so we're using the chi-square distribution. Remember, that's the one that's starts at 0. It doesn't have 0 in the middle, and it's not symmetric. We're looking for area to the right, because we're doing a right-tailed test, to the right of 10.105. Oh, and that was degrees of freedom. Remember, it's number of categories minus 1. We have 7 categories. Subtract 1 and you get 6 degrees of freedom. Just a comment, that's different than how we got the degrees of freedom before. The degrees of freedom before was sample size minus 1. Okay, so we're not using the 1,500 houses that we sampled as our sample size. Well, I mean, that's our sample size, but that's not giving us degrees of freedom in this type of test. You have to go with number of categories minus 1. Okay, so we go to our chi-squared table. 6 degrees of freedom, and I'm looking for 10.105. The closest we have here is 10.645. So I'm going to go up, and that gives me area to the right is 0.1. So the p-value is approximately 0.10. Okay, so 0.10 is what the table gives you there. And then what we do with that is we test it against the test statistic. So our we test it against our level of significance. Level of significance is, what was it, 0.05. Which of these is bigger? Well, 0.10 is bigger than 0.05. That's bigger. When your p-value is bigger than the level of significance, what do? Yeah, you do not reject the null hypothesis. It's not that that improbable that the observations that were made would have been made with H naught being true. So we don't have enough evidence to reject H naught. Of course, the way we state our conclusion is we say there is insufficient evidence at the alpha equals 0.05 level of significance to suggest household income distribution has changed since the year 2000. Okay, so we did not reject H0, so we're saying there's not enough evidence to support H1. Now, I want to back up just a minute and talk a little bit more about these computations. So, to me, it's not really my intent for you to sit with a calculator poking buttons with this many numbers. Okay, so to me, this computation is unwieldy if there's more than 2, 3, or maybe 4, maybe 5 categories. So I wouldn't ask you to do this by hand with this many categories. So on the homework, so that can comfort you for what you'll need to do during a test. Now on the homework, there probably will be more categories.